Hey everyone, and welcome. Today, we're diving into something really cool from Google Research called nested learning. It's a totally new way of thinking about how AI learns, and honestly, it might just be the key to solving one of the biggest headaches in the entire field.
So think about it. We have these AIs now that are just brilliant. They can write code, they can craft poetry, they can explain things that make my head spin. But here's the crazy thing. They have this kind of digital amnesia. They really struggle to learn new stuff without just forgetting the old stuff. So that's the big question we're asking today. Why do these incredibly smart AIs have such a crippling memory problem?
So here's how we're going to break this down. First, we'll really define this memory problem. Then, we'll look at the old way people tried to fix it and why it didn't quite work. After that, we'll get into the big idea, nested learning. We'll even meet a new AI model called Hope that's built on this idea, see how it did in some serious tests, and then wrap up by looking at what this all could mean for the future. Okay, let's kick things off. Section 1, AI's crippling memory problem. And I gotta say, I love this subtitle, The Paradox of Power and Amnesia. It just perfectly captures the whole issue, right? These models are unbelievably powerful, but they have this fundamental weakness when it comes to learning continuously. And really, the best way to think about this is to look at the gold standard, our own brains. Our brains physically change and rewire themselves when we learn something new. It's called neuroplasticity. But large language models, for the most part, they're kind of frozen in time. All their knowledge is locked in from their initial training, or they're stuck with this tiny short-term memory window. It's a huge, huge limitation. And this whole problem, this digital amnesia, it actually has a name in the field, catastrophic forgetting. It's exactly what it sounds like. You try to teach a model something new, like about events that just happened, and in the process, it just overwrites and forgets skills it used to have. It learns one thing but completely loses another. And that right there, that's the mountain researchers have been trying to climb. So that leads to the next big question. Why has this been so hard to solve? Well, it takes us to our next section, which explains why this has been such a tough nut to crack. Turns out, there was a major roadblock in how researchers were even thinking about the problem itself. You see, for the longest time, the world of machine learning kind of split these two ideas in half. On one side, you had the model's architecture. You can think of that as its permanent blueprint. And on the other side, you had optimization. That's the training part, the rules for how it learns. And for decades, people worked on one or the other, but they were always seen as two totally separate things. And this, right here, is where everything starts to change. This is the big breakthrough. The team at Google basically stepped back and asked, wait a minute. What if this separation is the problem? What if we've been looking at this all wrong the whole time? And boom, this is the core idea, the big aha moment. The big idea with nested learning is that the blueprint of the model and the rules for how it learns, they aren't separate at all. They're basically two sides of the same coin, just operating at different levels and moving at different speeds. So, this gives us the official definition of nested learning. It's a way of seeing an AI model not as one single thing, but as a whole system of smaller learning problems all nested inside of each other. The best way to picture it is like those Russian nesting dolls, you know? You open one up, there's another one inside, and another inside that. Each one is its own little learning machine, doing its own thing at its own pace. So let's break that down. It's really three key ideas. First, you see the model as this system of nested problems. Second, each of these little problems is learning from its own unique stream of information. And third, and this is the absolute key, each part can update at a completely different speed. It's a lot like how our own brains work, right? Some things we learn in a flash, and other skills, well, they take a lifetime to really sink in. Okay, so this all sounds amazing in theory, right? A totally new paradigm. But the real question is, does it actually work? Well, that brings us to section 4. And to an AI model called Hope, which is built specifically to put this new idea to the test. So what exactly is Hope? It's an AI built from the ground up on these nested learning principles. It has something called a continuum memory system, which is, a fancy term for something really cool. It has different kinds of memory that learn at different speeds. But honestly, this is the part that blows my mind. Hope can actually optimize its own memory. It's in a constant loop of learning how to learn better, basically upgrading its own software as it goes. All right, so this is where it gets real. Time to put Hope to the test. The team basically set up a showdown, putting Hope head-to-head with some of the other big-name AI models out there to see if this new philosophy actually paid off. And the results? Well, they speak for themselves. On really fundamental tasks like language modeling and just basic common sense reasoning, Hope came out on top again and again. Now, you see two things here. Higher accuracy, that's easy, higher's better. Then there's perplexity. All you need to know about that is that a lower score is better. It means the model is less confused and more confident in its predictions.
But what about that core memory problem, the catastrophic forgetting we talked about? Well, for that, they use the needle in a haystack test. This is a super tough test. They basically hide a tiny piece of information, the needle, inside a massive wall of text, the haystack, and see if the AI can find it. And as you can see, Hope's flexible, multi-speed memory system gave it a huge advantage. It was way better at finding that needle than the competition. So this is all incredibly promising, but what's the bigger picture here? Let's zoom out for our last section and talk about the future, because this is about way more than just one cool new model. It's about a whole new way to build AI.
I think this quote from the research paper itself just nails it. By stopping the separation, by treating the blueprint and the learning rules as one single system, they say they've unlocked a new dimension for design. Basically, it lets them build AIs that can think in more complex, layered ways than ever before.
So if you're going to take one thing away from all this, it should be this. Nested learning is a huge step forward. That giant gap we talked about at the start, between our brains that learn and grow and AIs that kind of get stuck, this is a real tangible step toward finally closing that gap. And that just leaves us with one final, kind of mind-bending question to think about. If we can really solve this problem, if an AI can learn and grow and absorb new knowledge forever without ever forgetting, what's the limit? What couldn't it learn? Something to think about. Thanks for tuning in.